The objective of this practice is to know and use the equipment in the laboratory. In this case, we use the impact testing machine, impulse pendulum sharping, and how to use it, but also to carry out the normalized test of impact letters to different temperatures and to interpret its results.
The first step of the impact test is to calibrate the machine. To do this process, we have to move this arrow to the value 264. Then we need to move the safety latch, and then we need to move the lever in this direction. To see that the arrow moves to the 0 value, that means the machine is calibrated. For this test, is needed to be done with two pieces of material in two different temperatures. The first is the environmental temperature, and the other is cold temperature. In this case, we're going to measure the temperature of the steel piece 1018, which is minus 9 degrees. Once the machine is calibrated, we need to put or position our piece of metal. In this case, we are going to work with steel 1018. We need to face or put this face to this direction in order to work properly with the pendulum. The first step is to put the piece in the bed with the notch in the center, like this. Then we need to put the arrow in the value that we said earlier, that is 264. Then we need to move again the safety latch and to move the lever again to make the pendulum move and break the piece of steel.
Okay, for the result analysis, first the impact test is a result of the single brittleness of the pieces, and for this practice we use the method sharping. So for the results we did 4 tests, 2 for the same materials and the other 2 the same, but we changed the temperature in the both of the 2 tests for the same piece. We can see for the absorbed energy in the impact test for the steel 1045, it has a result of 14 pounds per feet, and we did the same process for the other 3 materials. We used the steel 1080 also in 25 degrees, and we can see also the absorbed energy. We did the same process for the steel 1045 and the steel 1080, but we changed the temperature of these pieces for minus 11 degrees. Seeing the results of the pieces in the pieces, we can determine the type of fracture. For the steel 1045, we have a fracture of brittle that has no or little plastic deformation, and the other 3, the steel 1080 at 25 degrees and the other 2 are minus 11 degrees. These materials have a fracture of ductile type that has a plastic deformation in the pieces. Yeah. Okay. This depends on the percent of carbon that the pieces have. As we know, the steel 1045 has a more resistance than the 1080. This is because it has a more percent of carbon in the material. For example, in the steel 1045 it has a 0.45% of carbon than the steel 1080 that has a 0.80% of carbon, and this measures the hardness of the pieces.
Yeah.
Okay, the temperature also affects the piece because it changes the properties of the material, so it can be more or less resistant for the impact testing.
Resistance. The ability of the material to resist of shock and energy when breaking. The tenacity of this material depends on the temperature and shape. This is a Sharpie test. This consists of put in horizontal position in the specimen with the notch in front of the impact tool. This specimen needs to have 55 millimeter length. This is the ISO test. The difference between the Sharpie test is that we have our piece in a vertical position and our length is 75 millimeters length.
We can see here an example of a ductile fracture. We can see here this type happens when excessive plastic deformation happens. This is the fragile fracture. This happens before or during the plastic deformation. It is more common in non-crystalline materials at low temperatures and with a high stress. The temperature at which the material behaves in a fractional test depends the change of ductile to build on the rate of the deformation. One of the main applications for this practice is the crash test, which is used in the automotive test and also for measure the quality of the materials of safety like helmets and knee pads.
We need and we use the impact test in order to know the force necessary to reach the breaking point. This process is essential in the design process because this process gives us the information necessary to know how it's going to react our materials in certain areas or certain scenarios.
I learned that it's important to know that the same material can act in a different way according to its temperature. It can become more brittle or ductile.
In this practice we see the differential of the mechanical properties of the pieces in the different temperatures. Using the impact test we can determine the brittleness of the material.
In conclusion, I learned that this process is very used since it is practical and useful in the industry, and therefore it is important to know how to do it, so we can know how fragile a material is in relation to an impact.